Welcome back to the channel, everybody. Today, we're diving deep into the world of networking, but not just any networking. We're talking about the protocols that every hacker absolutely needs to know. Whether you're just starting your journey in cybersecurity or you're already a seasoned pro, this video is your one-stop shop for understanding the backbone of how data travels across the web. We're breaking down the top 10 protocols, how they work, and why they're so crucial for both ethical hacking and defending against attacks. So, buckle up, grab your favorite drink, and let's get started. Welcome to our channel. Today, we're diving into the top 10 networking protocols every hacker must know. Whether you're a beginner or a seasoned pro, understanding these protocols is crucial for navigating the digital world. Let's kick things off with the foundation of the internet, TCP/IP. It's a suite of protocols dictating how data is transmitted online. Think of it as the internet's language. Every device uses TCP/IP to communicate. TCP ensures data reliability, breaking it into packets and reassembling them. It's like sending a registered letter. IP handles addressing, giving each device a unique address. This way, data packets know their destination. Mastering TCP/IP is crucial for both cybersecurity and safe browsing. Next up, we're tackling the protocols that power the web, HTTP and HTTPS. HTTP, or Hypertext Transfer Protocol, is the foundation of communication on the World Wide Web. It's how your browser talks to websites, requesting web pages, images, videos, and all that good stuff. Think of it like sending a postcard. It gets the message across, but anyone can read it along the way. Now that's where HTTPS comes in. HTTPS stands for HTTP Secure, and it adds a crucial layer of security by encrypting the communication between your browser and the website. It's like sending that same postcard in a sealed envelope. Only the intended recipient can see what's inside. By analyzing HTTP requests and responses, hackers can uncover vulnerabilities, steal sensitive data, and even inject malicious code into websites. But knowing how these protocols work also empowers you to protect yourself. So whether you're building a secure web application or just trying to protect your online identity, mastering HTTP and HTTPS is essential. Let's talk about FTP, or File Transfer Protocol. A veteran in the digital world, it's the go-to method for transferring files between computers on a network. FTP works on a client-server model, but it's notoriously insecure. Data transferred via FTP is often unencrypted. Using SFTP or SSH File Transfer Protocol encrypts the connection. It's a much more secure way to transfer files. Understanding FTP and its secure alternatives is crucial today. Let's talk about DNS, the domain name system. It's the internet's phone book, translating domain names like google.com into IP addresses. It's easier to remember google.com than a string of numbers. When you type a domain, your computer contacts a DNS server for the IP address. The server sends it back, connecting you to the website. Hackers can exploit DNS to redirect you to malicious sites, use reputable DNS servers, and enable DNS SEC. Be cautious about the links you click. Understanding DNS helps you stay safe online. Let's move on to a protocol that's near and dear to our inboxes, SMTP, or Simple Mail Transfer Protocol. As the name suggests, it's responsible for sending and receiving emails, making it one of the most widely used protocols on the internet. Think of SMTP like the postal service for your emails. When you hit send, SMTP takes your message, packages it up with the recipient's address, and routes it through a series of servers until it reaches its destination. Using email providers that implement robust security measures, enabling two-factor authentication, and being wary of suspicious emails can significantly reduce your risk of falling victim to email-based attacks. So, whether you're managing a corporate email server or just trying to keep your inbox free of spam and phishing attempts, understanding how SMTP works and the threats it faces is essential in today's digital world. Alright, let's dive into a protocol that's essential for managing and monitoring devices on a network, SNMP, or Simple Network Management Protocol. It's like having a remote control for your network devices, allowing you to collect information, configure settings, and even troubleshoot issues from a central location. Think of SNMP like a chatty neighbor. It constantly sends out messages to devices on the network, asking for updates on their status, performance, and any potential issues. Using strong, unique passwords for your network devices, disabling SNMP if you're not using it, and keeping your SNMP software up to date can significantly reduce your risk of falling victim to SNMP-related attacks. So, whether you're a network administrator or just a home user with a router, understanding how SNMP works and the threats it faces is crucial for maintaining a secure and reliable network. 6. Let's move on to a protocol that's beloved by system administrators and security professionals alike, SSH or Secure Shell. It's the go-to method for establishing a secure encrypted connection to a remote computer, allowing you to manage files, run commands, and even access graphical interfaces as if you were sitting right in front of it. Think of SSH like a secret tunnel between your computer and another computer on the internet. It encrypts all the data that passes through it, making it virtually impossible for anyone to eavesdrop on your communication or steal your credentials. Using strong, unique passwords, enabling two-factor authentication, and limiting SSH access to specific IP addresses can significantly reduce your risk of unauthorized access. So, whether you're a seasoned sysadmin or just starting to explore the world of remote access, understanding how to use and secure SSH is essential in today's interconnected world. 7. Let's talk about a protocol that's been around since the dawn of the internet, but is often considered a relic of the past: Telnet. It's a simple, text-based protocol for remotely accessing and controlling computers. And while it might seem outdated, it's still used in some niche cases like managing legacy systems. Think of Telnet like sending a telegram. It gets the job done, but it's not exactly secure or private. That's because Telnet transmits data in plain text, meaning anyone snooping on the network can potentially read everything you're sending, including usernames, passwords, and any other sensitive information. For hackers, Telnet is a prime target. They can easily sniff network traffic for Telnet connections, capture credentials, and gain unauthorized access to systems. So unless you're dealing with legacy systems that absolutely require Telnet, it's best to steer clear of this outdated protocol and opt for more secure alternatives like SSH. Your data and your peace of mind will thank you. Let's explore a protocol that's often used for network diagnostics and troubleshooting, ICMP, or Internet Control Message Protocol. It's like the network's echo, sending out messages to test connectivity, report errors, and provide valuable information about the state of the network. Think of ICMP like sending a ping-pong ball across a table. If it comes back, you know the connection is good. Firewalls can be configured to block excessive ICMP traffic, and intrusion detection systems can alert you to suspicious ICMP activity. So, while ICMP is a valuable tool for network administrators, it's important to be aware of its potential for misuse and take steps to mitigate the risks. 6. Finally, let's wrap things up with a protocol that's essential for connecting devices on a local network, ARP, or Address Resolution Protocol. It acts as a bridge between the physical world of MAC addresses and the logical world of IP addresses, allowing devices to communicate seamlessly on a network. Think of ARP like a receptionist at a hotel. You give them the guest's name, IP address, and they tell you their room number, MAC address, so you can find them. Using static ARP entries, implementing ARP inspection on your network devices, and being cautious about connecting to unknown networks can significantly reduce your risk. So whether you're managing a corporate network or just connecting to your home Wi-Fi, understanding how ARP works and the threats it faces is crucial for maintaining a secure and reliable network environment. 6. That's it for our deep dive into the 10 networking protocols every hacker must know. We've covered a lot of ground, from the foundations of TCP/IP to the intricacies of ARP spoofing. Remember, understanding these protocols is not just about hacking, it's about gaining a deeper understanding of how the internet works and how to navigate it safely and securely. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe for more content on hacking and cybersecurity. Stay safe out there. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe for more content on hacking and cybersecurity. Stay safe out there.